Alright, so radical expressions, how to rationalize the denominator. First example, 8 over the square root of 3. Okay, we don't want the square root of 3 in the denominator, we want to make sure we can simplify this. How do I get rid of the square root in the denominator?
You do the square root of 3 over 3.
Okay, so you want to multiply this both by the square root of 3 over the square root of 3. Very good. On my numerator, I get 8 times radical 3, which is 8 radical 3. My denominator is radical 3 times radical 3. What is radical 3 times radical 3?
3.
3, very good. This is the same thing as saying radical 3 times radical 3 is the same thing as saying radical 3 squared. And if you think about this, the square root and the square inverses simplified, and you're just left with 3, which is why that goes away, okay? So then you're just left with 3 into the denominator. Always check to see if you can simplify your coefficients, 8 and 3. In this case, can you? No? So you're just left with 8 radical 3 over 3. Next one, 2 radical 5 over 3 radical 2.
Would you times them both by 3 radical 2?
Okay, the only thing I really want to get rid of is the radical 2. So I don't have to multiply by 3 radical 2. I could just simply multiply by
Radical 2.
radical 2. Good. So multiply both numerator and denominator by radical 2. My numerator is 2 times 1, which is 2. Radical 5 times radical 2 is radical 10. My denominator becomes 3 times radical 2 times radical 2, which is 2. So here I have 2 radical 10 over 6. Can I simplify?
Yes, you can simplify both by 2.
Good. Simplify both of these by 2. This becomes 1, 3, or just radical 10 over 3. So here we have 5 radical 30 over 8 radical 640. What I want you guys to highlight here, okay, is looking at this problem, just take this piece into consideration for a second. You have radical 30 over radical 640. Now, some of you guys might be thinking, let me multiply this by radical 640 to rationalize. Do not do that. Your numbers will get huge. You don't want to make that much more work. All right. This right here is the same thing as saying square root of 30 over 640. Can I simplify this?
Yes.
Yeah, well, they both end in zeros, so there's that. And now 3 and 64. Can I simplify 3 and 64? No. Well, I can't divide 3 into 64, but square root of 3, square root of 3. What about the square root of 64? Can I rationalize that? Square root of 64 is?
8.
So really what I have here is 5 radical 3 over, and this bottom piece is what? 8 times 8, which is 64. Do I have to do anything else? No, just check your coefficients. 5 over 64. Can they simplify? No. Answer is complete. So before you start multiplying by radicals, always try to simplify both your radicals in the numerator and denominator and see if that could be helpful. Alright, let's take a look at a different type. So 5 plus 2 radical 2 over radical 8. Alright, so now we have a binomial in my numerator. Again, same strategy. Multiply both numerator and denominator by square root of 8. For a good practice, I would put that binomial in parentheses. Any reason why? Anybody know why I might do that?
Because you're going to distribute.
Yeah, it's going to remind me that I'm going to distribute the radical 8 to both these terms. So 5 times radical 8 is 5 radical 8. And then 2 radical 2 times radical 8 becomes plus 2 radical 16 over radical 8 times radical 8 is just 8. Always check. Can I simplify anything else?
Well, couldn't you simplify the 8 before you started?
You could have simplified the 8 before you started, absolutely. You could have done that. That's one strategy. You could simplify this 8 before you started, absolutely. You could have also, rather than multiplying by radical 8, you could have multiplied by what? Radical 2, because if you multiply radical 8 times radical 2, you would get radical 16, and the square root of 16 is 4. So that could be another strategy, absolutely. So there's a couple different strategies you could take on this one. Whatever works the best is use it. Yep.
Well, for that, couldn't you simplify 16?
Yeah, in this one you could keep going. So you can still simplify 5 radical 8. 8 you can break up into what? What two factors? 4 and 2. So this is actually 5 times 4 times 2 plus 2 times radical 16 is just 4 over 8. Square root of 4 comes out as a 2, so 2 times 5, which is 10 radical 2 plus 8 over 8. Am I done?
No.
No, very good. Can I simplify any further?
Yeah.
Okay, so look at your coefficients. You have 10, 8, and 2. Do I have a common factor going into all three of these? 2, okay, so this 10 becomes a 5, this 8 becomes a 4, this 8 becomes a 4, so my final answer will be 5 radical 2 plus 4 over 4. Can I simplify just these 4's here?
No.
Very good, okay, has to go through all of them. Okay, let's look at another one. Same type, binomial over single term, binomial. 2 radical 18. So in this case, let's look at this one a little easier. Rather than multiplying by radical 18, what can I do now?
You can simplify?
Yeah, I can simplify my radical 18. Radical 18 can be broken up into what? Square root of 9 times 2. Very good. Square root of 9 is 3, so I have 3 times 2. Bringing this 2 down here. So my denominator is actually what? 6 radical 2. And my numerator so far stays the same. So now when I want to rationalize this, what am I actually going to multiply my denominator by?
Radical 2.
Excellent. I'm going to multiply both numerator and denominator by radical 2. I'll put my parentheses here to remind me to distribute. 5 times radical 2 is 5 radical 2 minus 2 radical 5 times radical 2 becomes 2 radical 10 over, and this becomes 6 times 2. Radical 2 times radical 2 is 2. And 6 times 2. So my numerator simply says 5 radical 2 minus 2 radical 10 over 12. Can I simplify any further?
No.
Put a box around it, you're done. Go ahead.
Okay, so you can simplify like the 2, the 10, the 12, like the inside.
Right, and the reason why, like in order for you to simplify that way, you have to be able to simplify all 3 coefficients. Okay, it has to be something that comes out of all of them, not just 2 of them.
Well, no, what about the other way?
Inside the radicals?
Yeah.
No. No, not inside the radicals, right. Okay. Alright, so now we've got a binomial over a binomial, okay? 4 plus radical 5 over 3 minus radical 3. So can you remind me, how do I simplify this piece?
You would multiply by 3 minus radical 3 over 3 minus radical 3.
Close.
You would multiply by the opposite of the sign, so it would be 3 plus radical.
And what's multiplying by 3 plus radical 3? What's that word? Good. Multiply by the conjugate, okay? And again, multiply both numerator and denominator by the conjugate. I'm going to put parentheses everywhere, so I know I'm going to FOIL both these terms. Okay, I'm going to FOIL my numerator first. 4 times 3, 12 first. Outer, 4 times radical 3 plus 4 radical 3. Inner, radical 5 times radical 3 plus 3 radical 5. And then last, radical 5 times radical 3 plus radical 15. And if you want to simplify this first before you do the denominator, that's fine. You know, by all means, whatever you want to do. In this case, you can't simplify anything here. 12, you can't simplify with anything. None of my radicals are the same. This is radical 3, this is radical 5, this is radical 15. Can't simplify to 3, can't simplify to 5, can't simplify to 15.
Can you do like 3, 4, 12,
The only way I could add these all up is if they had the same radical.
Oh, okay.
Okay, so if this was 12 radical 3 plus 4 radical 3 plus 3 radical 3, then I could put those together.
Yeah.
And then my denominator. Now my denominator, I'm multiplying it by the conjugate because I want the 2 middle terms to cancel out. So let's see how they cancel out. So 3 times 3, we got 9. 3 times radical 3 is positive 3 radical 3. Negative radical 3 times 3 is negative 3 radical 3. And then negative radical 3 times positive radical 3 is negative. Radical 3 times radical 3 is 9. So my numerator stays the same. So 12 plus 4 radical 3 plus 3 radical 5 plus 15. My numerators simplify. I'm sorry, so I have a mistake here. This should have been a 3, not a 9. Good, thank you. Over, and then 9 minus 3, again, answer of 6. Now I'm going to ask you a question. Can I simplify the 12, the 4, and the 3 with the 6? No, okay, good. So you have 4 terms on top. All 4 terms would have to have a common coefficient or with a common factor. Okay, this one, the 15, this was square root of 15, sorry. The square root of 15 doesn't have a common coefficient. Okay, so I can look at one more. Okay, so 5 plus 4 radical 3 over 2 minus 3 radical 2. Okay, what am I going to multiply this one by? Go ahead.
2 plus 3 radical 2.
Good, the conjugate will be 2 plus 3 radical 2, both numerator and denominator. Okay, for practice, I'm going to put these in parentheses. And I'm going to FOIL. So first, radical 5 times 2, 2 radical 5. Radical 5 times 3 radical 2 becomes plus 3 radical 10. Inner, outer, FOIL. 4 radical 3 plus 2 becomes positive 8 radical 3. And 4 radical 3 plus 3 radical 2 becomes positive 12 radical 6. Can I simplify anything in my radicals? Can I simplify radical 5, radical 10, radical 3, radical 6? Can't do anything, so my denominator stays just the way, my numerator stays just the way it is. And my denominator. So I'm going to take a shortcut on this one. Alright, so pretty much what you're doing is you're taking this first term, 2, and you're squaring it. You have a negative times a positive, which is a negative. And then you're taking the last term, 3 radical 2, and you're squaring this one. Okay, so that's pretty much what we're doing here. So if you take that into consideration, I'm going to bring that down here. So 2 squared is actually 4 minus, and then 3 radical 2, what would that be squared? 3 radical 2 squared. What's 3 squared? 3 squared? 9. Radical 2 squared? 2, so I have 9 times 2, which is 18. And then 4 minus 18, and I get an answer of negative 14.